robot lives matter and all. I mean,
Yeah.
No, if you just get you some fake tan and a little more hair, dude, you're ready to go.
A little more.
I'm being politically correct here.
Okay, yeah, all right, that sounds good.
Yeah, he may have as much hair as Trump does.
Yeah, well, I could even have more. You never know. All right, Harold, were you recording that nonsense?
Yes.
Oh, awesome. All right, so let's just kick this off and get on with it. So, welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual. I'm Carl, the sitting president for at least the next month and a half. But there's no election fraud here. I can guarantee that. There's no elections at the moment. Anyhow, we're going to do the usual thing and float around the table to see who has what to show and share and talk about. Always take crowd challenges for can't get this or that to work. And we'll probably talk a bit about our forthcoming contest featuring the ever more increasingly amazing line-following simulation environment. So in our effort to zoom around the table at whatever pace is comfortable, let's start off with Doug, our chosen starter, and then we'll just walk around randomly until we run out of steam. Doug, take it away.
Okay, so today I got to actually, or not today, this week I got to actually play with my robot. I drilled holes in the front of the body here so I could put these ultrasonic sensors in. I wish I could put that line up the camera better. There we go. So I put ultrasonic sensors on both sides so that I should have a good view of the front. And I changed out my Uno Nano with an Uno Mega and got to play around with the monster number of pins and figuring out which one was which. I got that all working, but I wasn't able to get the ultrasound actually working yet. I'm still in the middle of upgrading that. So we can't see it running around, but it does. The motors are back in control again, and I started my subsumption architecture so that I would have my real robot control program started. It goes out and it checks all of its sensors and determines if it has some reason to stop, and if not, it follows the last command that was given. If it finds something, then it will tell the higher up module, which is going to be a Raspberry Pi, I got a problem. You figure out what I should do next and then tell me. So that's where I'm at right now.
Wait, so you're jumping straight away in with the subsumption architecture?
Oh yeah, I actually didn't know there was a word for that, but that's what I was planning on doing all along, is you check the environment and see if you're going to hit anything, because we don't want to hurt anybody or ourselves. And if that doesn't work, then we continue to wander around the space, do what we're going to do.
Oh, but are you implementing sort of subsumption architecture in the literal sense, right, as originally published by, by Brooks, with the actual notion of, some reflex, subsuming another reflex, and I don't remember all the details, or are you just doing something like it?
Probably just doing something like it. Let me bring up my program here real quick.
Right, because, a lot of what we do ends up being, some form of, reflex-based logic or reactive logic, but, I just treat that differently from, let's say, true subsumption architecture.
Okay, so I hope you can see my code here.
Mm-hmm.
And so getting into the setup, and right now the loop just says, go check the subsumption stuff. And when it returns, it's either going to stop or it's going to follow the program. The subsumption stuff, if I'm doing it correctly, I'm just guessing because it's what I intended to do, is the subsumption check is going to check all the sensors in the direction of travel. Right now I have one. And then if it doesn't find any problems, it's going to check the next thing it should check, which is compute if anything's fixing to run into me. And if it doesn't find any problems there, it's going to return a 0. If it finds any problems, the problem is going to come back with a non-zero. And it's going to notify the higher computer so it can do the thinking. And here's the code for that check there, but that's not important. So basically, I hope I answered your question. and it checking a bunch of things real quick, because that's what the Arduino is supposed to do. And if it finds any problems, it stops and lets the boss decide what to do next. If it doesn't find any problems, it continues with its program. That's what I'm calling.
So what did your program do at this point? Just, go
Right now,
forward and
right now, all it can do is run the motors forwards, backwards, left, and right. I was doing a motor check, and it still can do that. And the next thing, I'm wiring up these ultrasounds so that I can begin the checks for the subsumption. And I'm going to be implementing the first of the high-level commands, which is go forwards. And then I'll implement, if you found something on the left sensor, turn right. If you found something on the right sensor, turn left. That's the beginning of what I'm working on right now. And then I'll put some side sensors and some back sensors and add other things as I go along.
So Chris,
And-
how does that fit within your understanding of it?
I guess, yeah. I mean, I think it's not pure subsumption as I understand it. I have to admit I've never implemented it myself, but I remember from way back when what got me started in all this was grad school, and one of my assignments was reviewing that paper from Rodney Brooks. So it's been a number of years since I've actually read about it. But what I do remember again is sort of the notion of, you have these almost competing behaviors going on. Let's say one behavior saying, well, go towards the light, right? If you have a light sensor, but then you're always in parallel checking maybe for sound, right? So if you hear a sound and it's too loud, you do something else instead, right? So there's this notion of competing behaviors, and you got to decide, well, what takes priority, right? And subsumption has its way of doing this whole prioritization of the action, right? Because each behavior kind of wants to do something with the motors, but at some point, you can only send one set of, PWM values to the motor. So what subsumption does is, with this whole notion of subsuming and inhibiting certain things, right, you end up prioritizing, right? You have a mechanism by which you choose which behavior gets the final word on what to do. And, there's, a number of different ways to actually implement it, I'm sure. But to me, that's kind of one of the essential aspects of it, right? So having these multiple behaviors that end up, competing. I mean, competing may not be the right word, but that end up sort of running at the same time, and you have to somehow combine their output.
So that's not exactly what I'm doing. I admit I have not read his paper. Mine is strictly, it has a bunch of things that can say, I've got a problem, and it checks them in order. And the first one, it says, I've got a problem. It stops checking and says, we have a problem, do something about it.
I'm just looking at my bookshelf because there was one book, and I thought the other day someone mentioned it, by Jones, perhaps. So there's a book that's not too old that sort of goes into the details of implementing it. Let me just double check here someplace.
And Dave Anderson has some pretty good videos, I think, on the DPRG YouTube.
Yeah, that's what taught me the word.
Yeah, there you go. Yep, behavior-based robotics.
Oh.
Yeah, so that is by Joseph Jones, and he, I guess he does his version of subsumption, but I think it's actually a good book, and covers it in a lot of good detail. I think I have some others. I have to go back and look at my bookshelf. But yeah, so that's again, when you said subsumption, that's what I started thinking. Okay, multiple behaviors and somehow combining these things, and there are different ways of doing it apart from subsumption. But at the end of the day, right? I mean, that is always sort of the challenge, right? You have maybe a wall following logic that's trying to do something like maintain a fixed distance to the wall, and at the same time you are maybe you have a little bit of obstacle avoidance, right? If you run into you see something that's right in front of you. So whether it's pure subsumption or not, the notion of multiple behaviors or reflexes going on in parallel and wanting to take control of the motors, I think that's a constant in most of our programming styles, right? I mean, you always have that challenge of having to choose one somehow. Does the wall follower get to decide, the steering angle and the motor speed, or does the obstacle avoidance logic get to decide, right? You have to have a way of choosing one, and sometimes it's clear and obvious, and sometimes it's not.
Don't we have the Asimov three laws that just defines this for us already?
Program one way. I was thinking of another one, so I sat in a pilot training course once or twice, and they I remember this one thing where they say you got 3 priorities. It's aviate, navigate, communicate, and in that order. You don't bother navigating or communicating if you're about to run into a mountain.
Right.
So you aviate first, and then you navigate so that when you're not flying into a mountain, you're at least heading in more or less the right direction. And only once those are under control do you bother to pick up the phone and make a call. Aviate, navigate, and communicate. So maybe that's the airline's version of subsumption.
I had one other question, Doug, and that's any particular reason you've chosen the ultrasonic sensors over, let's say, the popular sharp IR, distance sensors that there's a lot of different versions nowadays?
Well, I have to admit I don't know what the sharp IR is. I've only just begun, so I know what I know, and I had that one car that used the sensor, and they used it for optic avoidance. And I also, when I got my Roby from Harold, one of the YouTube videos I looked up was the guy that was doing this with 2 of the ultrasound sensors. So I thought he never finished it, but I went ahead and started trying to implement it. I'll likely use some better sensors higher up because sensors down at the base are going to stop me from running over things. But anything that's higher than 6 or 8 inches, I could run into it anyway. I need other sensors. And
I mean, you may need a combination, right? I mean, the ultrasonic are good for certain things, and they have a wide range, right, which is good and bad. And the IR have a much more, tend to have much more focus, or even those, one-dimensional LiDAR sensors, which I have never used, but like these newer time-of-flight LiDAR sensors. Again, to me, that's equivalent to the old sharp IR distance sensors. They give you a very very narrow focus, which is sometimes what you want. So I found I kind of needed both actually in practice. The ultrasonics have their advantages and the IR have their advantages. The ultrasonic, I found the biggest problem for me always was if you're facing something that's very soft, like an animal or a stuffed animal,
not everything reflects.
Might not get an echo back. Right, it absorbs the sound, and if you're facing the wall, right, I don't know how to do this here. Okay, if you're facing the wall at some angle,
very shallow angle, yeah.
It's just going to bounce right off, and you're not going to get an echo, right? So that's the other thing to watch out for, and that's why combination of ultrasonic and IR is, you may end up with something like that.
Yeah, I had intended to do that because I knew that the ultrasonic had some problems, and I was going to use IR for side and back, and probably will put some in the front too. I chose the ultrasonic because their distance would give me time to make a decision before I got up to something. And the IRs you have to be pretty close before they start firing off. And I drive my robot full speed into a wall and then it hit the wall. Where did that come
the IR, some of them go out like even 2 meters, but then the problem with some of them is the further out they go, the further away you have to be also. Like there's a minimum detection range too, right? So it's kind of a bit of a trade-off. Again, I haven't used those newer time-of-flight laser distance things yet. I mean, those are maybe that's what I would be looking at if I were to buy more sensors. But some of them look very promising in terms of both the range they give you and minimum distance and that, you know, and precision. I mean, there's a lot of good new sensors coming out that look very promising.
Thanks.
These are some really old sensors, pump switches. You know, they take no power. You know, I've got 4 of them. One to detect where I'm close enough to the can here. The lever switch, 2 bumper switches here. Another. If I can show that. This is just another switch here for when I go into the goal for can soccer. So they work really well.
Yeah, that's basically why I've changed from the Nano to the Mega. I needed pins to be able to handle multiple sensors.
Yeah. Bump switches are good.
Well, cool.
Yeah,
So that's good progress.
You know,
All right.
we're going to respond to every surface that you're going to, you know, shoot a light beam across, or sound waves, or, you know, they all have their flaws. So
Right.
I guess.
Oh, and one more question I had. You mentioned you're gonna hook up a Raspberry Pi and you're gonna let it make certain decisions. I mean, are you planning to hook up some other sensors or something else, so like a camera that you need a Pi for processing, or you just kind of want to use a Pi just for the fun of it?
All of that. I am going to be hooking up cameras, and the Pi, I expect it to be able to program more easily to make the higher level decisions. I was thinking that the Arduino was fast, so it could handle the sensors and the motors, and the Pi had more programming space to handle more programs. I don't think all of my programs will fit on the Mega. It's just too small. And I am going to have a camera, so all my Pi programs use that OpenCV stuff.
Oh, okay.
The big facial recognition and who knows what else. Object moving.
And what's your plan for connecting the Pi to the Arduino? Are you going to use Fermata, which was talked about here, or are you going to use something else?
I haven't determined my exact plan yet. I had intended to use IC squared or I squared C, whatever that was, but y'all keep talking bad about that. I thought about maybe just, you know, I can use some of the pins and do some GPIO and have my own bits that add up to a byte and say, okay, if those bits add up to an 8, do this. And you decide.
I mean,
Hey, Doug, I think where you got
the
some
most
stuff.
fail-proof approach would in the end always be, in my opinion, just the UART, right? Just the bidirectional, this standard serial link, right? I mean, that's a little less finicky than I squared C, and it's bidirectional if you set it up that way. I mean, that's just one option that you can consider, right? Because the Arduino Mega has plenty of serial ports.
Right.
So you're not even losing a serial port that you might otherwise need for, you know, your printfs. And the Pi, okay, doesn't have a ton of serial ports. The latest one, I think, has 2 serial ports, right? I mean, 2 UARTs. So that would be one way to go.
That should work.
Yeah, Doug, you may be conflating a couple of things here. I squared C or I2C versus what Chris was just talking about with the serial stuff. That's an underlying protocol for passing information. What Fermata is, and other things, those are actually information packets that ride on that underlying protocol. So in the case that Chris was talking about, when he's talking about UART, you're just sending text commands back and forth between the two. And you define those commands, right? And like the Fermata stuff that's come up before and come up that I'm using in mine currently, I don't think I'll end up using it totally in the whole side of thing. There is a protocol that rides on top of either a serial or I2C, and I think they can even do Ethernet now on the thing. But that Fermata is a communication contract that rides over the top of that communication protocol. Does that make sense?
It does make sense,
Okay.
and I'll be looking into that when I get to that part of the program.
Yeah.
don't know, maybe, Carl, have you had bad experiences with I2C? I mean, I use it quite a bit. I just send 1 or 2 bytes of information from like a Raspberry Pi to a Mega. It's worked reliably. We've used it extensively with, you know, I'm drawing a blank here. The cars that you train to run around.
Donkey car.
That's what Donkey Car uses. Seems fairly reliable. Have you had that bad of an experience with I2C?
Who?
Carl, have you had that bad?
Oh no, I haven't messed with it that much yet. In fact, I was hoping to lean on it a lot. The one I played with most recently was Spy.
Oh, okay.
And I did it in the backwards way from the normal way because I did it so that the Raspberry was the master on the Spy side and the Arduino was the slave.
Yeah.
And what that meant was that I was demanding more real-timey things out of the Pi than it could handle. And then it had kind of limitations on the Mega side because I really had to slow it down from its maximum bus rate just so that I could be sure to capture the packets most of the time.
Uh-huh.
So I think at the end of the day, it's still, even though it was a Spy port and Spy bus, you would have expected it to be faster than some of the others. I think in effect the upper end was no better than I would have done on a serial. Or I don't know. I haven't looked, and I was going to look at I2C just because it seems to have libraries that better support bidirectional stuff for the Mega, for the Arduino side. Because I really had to do some kludges to make the Mega be a Spy slave.
Right. Yeah.
It really wants to be a Spy master.
Yeah.
When I was working at an automotive company, what I've heard is inside car, I2C is it's some variation of I2C communication.
Well, so I mean, let's face it, right? Because as I understand it, I2C was, I think that if you look it up, I think it stands for inter-chip.
Yeah, inter-circuit communication. It's like 2 inters right in a row.
It was meant for the world of consumer electronics 30 years ago, before there was systems on chips like we have in our phone now.
I think like
So
Philips
as
or
a
somebody.
protocol, it was not designed to be carried over foot-long wires when you have, you know.
Well, that's where CAN bus comes in.
Yeah.
Exactly. That's what the real
CAN bus is
right?
more able to handle interference.
It's canvas. That's right.
Yeah.
CAN bus.
There we go.
CAN has, I mean, fundamentally, it has what it has. If I've understood, at least in some variants, it has differential signal transmission, not voltage level like I2C. So there's David doing the differential dance.
Mm-hmm.
So differential signal dance going on, so it can handle electrical noise a lot better. And I've understood that it also has, like, as a protocol built in, it has maybe not guaranteed delivery, but it has options for things like that, so that it has some robustness built into the protocol itself.
If memory serves me, I2C was developed back in the 80s, 90s.
Yeah.
For like Philips to be able to for all these stereo equipment and TVs to communicate to one another. That was it.
Yeah, no, well, the chips inside on a big circuit.
Yeah.
Where you got controlled impedance and a printed circuit card, and you can manage the interconnect much better. So it's not at all for these dangly Dean's cords, you know.
Yeah.
Ground wires that you're lucky if it exists or not, but it's not designed. Yeah, just like David has there, Dave Ackley. So it's not really designed for that. It happens to work a lot, but good thing we're hobbyists instead of million-unit commercial vendors, right? Because they wouldn't survive the way we're using it.
Yeah, I don't think they
In the
do.
real world.
It's critical.
Space station or anything.
Carl, do I have audio?
Yeah. Hello.
Hi. I was just going to stick in my 2 cents worth. My experience is somewhat like Chris's. I would say that if you really need a high-speed interface, like, for example, you're talking to a gyroscope or something where you need to really, really sample accurately at high speed. It's real hard to beat SPI. It's easier to set up, and it takes more pins. But I got lots of boards that have all those pins on them and hardware interfaces. So, and then given that that's the case, my default, I just fall back on a serial interface. They're easy to use. You can talk ASCII across them, so they're easy to debug. They can run really fast these days. They're bidirectional. It's just real hard to beat. It's just an old-fashioned.
It's 3 wires, right? So it's
Yeah, ground.
Hey, I have a question about the speed of the serial bus. So this week, I was initially using the baud rate of 115200, something like that. That's like the highest written down the list of number. But then it was not very fast because I was transferring more data than that. It comes down to like this like 100K, maybe 10K. But anyway, it's just not enough. So I Googled and someone said I can set the baud rate higher, and I did. I didn't go to extreme, but I ended up putting it 1 million, like about 10 times. It just worked. So, I mean, I don't know how fast I can put it in. It was fast enough.
If you're talking over your USB port to serial, which a lot of us are, I think you can run that up to like 2.5 million or so, and not even have a problem. Well, it depends on the receiving side. You don't want to be dropping stuff on the other side, whichever you're coming until you start dropping stuff. Keep ramping it.
Yeah, I mean, even the Arduino will happily go above 115 to 100. You have to, look up sort of what baud rates it can support accurately, right? Because it's all tied to the clock speed. Ultimately, you can't support an arbitrary baud rate. You're gonna have a lot of error between what you tell it to do and what the actual rate is, right? It's all derived from Arduino is running 16 megahertz. Some other boards at 20 that use the Atmel. But it all comes down to that. So you can run at a 500K, even a megabit. But again, and I've made that point before, you got to make sure that you don't have too many things going on, and you end up missing interrupts, and therefore you end up missing incoming data on your Arduino. But yeah, it'll happily go up, easily to a megabit.
Well, yeah, that's what I'm using now, and it's working. It looks like I'm getting data, and the speed is good.
Yeah, but you get at a megabit, you have to think about it this way, right? A megabit, it's about 10 bits per byte, right, with the start bit and the stop bit.
Yeah.
So you're talking 100,000 bytes per second potentially coming in, right? Not obviously continuously, but let's say even a couple of them in a row. Which means you're getting an interrupt every 10 microseconds. Are you really pushing it, okay, with an interrupt every 10 microseconds? If other stuff is going on, right? If you have other interrupts firing because of other sensors you have connected, and there's a good chance you're going to miss an interrupt at that rate.
Inside Arduino, each bit is an interrupt.
Not each bit, but each byte.
Each byte.
Right, but again, at 1 megabit, it still comes down to 1 byte every 10 microseconds.
Okay.
So that's not a lot of time for an Arduino. If it's got nothing else to do, it's fine. But if it has other things to do also, then at that rate, I wouldn't be surprised if you miss some interrupts. Right, like if you have an encoder going on, and if that interrupt service routine is not terribly efficient. Right, and if that spends a couple microseconds already in the interrupt, and then something else comes in, and another, before you know it, you miss an interrupt.
When I demo, I want to show you guys what I put in. I mean, I was timing some stuff. So all right, yeah, thanks. But yeah, that's good to know. 1 megabyte is a good number to use. I mean, 1 megabit. I was really worried I was going to destroy this thing.
It's a possible number to use. I'm not suggesting it's a good number to use. You have to be careful if you push it that high.
Okay. All right.
Another thing to consider is how much bandwidth do you actually need? If you have, let's say you have an update rate for your robot, the one I'm currently running updates at 25 hertz. So that means 40 milliseconds of decision making and data collecting for each output. So if you have, I know we were talking earlier about infrasound sensors or infrared distance sensors, they can only return distances at a finite rate. So you can't collect more than a couple of dozen data points per second anyway. And probably 1200 baud is fine if that's all you're sending. So it's not just how fast you can communicate, but how often you need to and how much information you need to.
If I put it very high baud rate, but I don't transfer much data, it's not really wasting anything, right? It's just the interrupt doesn't trigger. Is that correct?
It's only in the sense of trying to avoid the situation Chris was describing, where your interrupts are coming in so fast that the machine, I mean, 10 microseconds, even for these little machines, that's not very much. I, of course, would suggest that you use an STM32 ARM board where all that's done in hardware and it doesn't take any microprocessor time. That's just me.
It's a plug.
What's the hurry to send so much data so fast if you're not sending so much data? I mean, 9600 baud will hand out 8 bytes real quick.
Well, the one thing I would say, you're right. I mean, you have to look at bandwidth, but sometimes it's not necessarily that you have a lot of data that you need to send, and maybe not even very often, but sometimes you want to do this transaction, this back and forth with essentially zero delay, right? Whenever I've looked at these setups where I have an Arduino type board connected to a Pi, I want there to be ideally zero latency in the communication. It's not a lot of data going back and forth. And again, not necessarily super often, unless you're trying to close a loop, on the Pi that, you really ought to close the loop, on the lower level board. But when you're trying to push it, you do have to look at sort of what's the latency as well, right? That can come into the picture, when you drop the baud rate too low, all of a sudden you're getting 32 bytes across, takes an eternity.
And you're putting the lag into control loops that can screw them up.
Exactly. That's what I mean.
In my case, I was initially, this is the time I'm transferring the most data because I want to bring all encoder interrupt data in. So it quickly added up to be, that 10 kilobytes per second was not enough. I was trying to buffer this, buffer that, and this like 63 bytes transfer buffer. I was just dumping my data into that buffer, and in the end, I was timing. It keeps locking up if I go fast. So I put in these monitoring mechanism. I was like looking at what is my buffer, how free is my buffer, and how much. In the end, I was counting how many bytes I'm transferring. Then I realized, wow, I'm transferring like the full speed. But then when I put this 1 million baud rate in, I don't have to worry about it. It just ran like 4 channel of data. Yeah, so I'd say faster is we don't want to tune the squeeze out the last bit of performance. I just want it to be plenty of room to spare, and that's. So I'm glad this 1 million worked, and otherwise I'd be having to I was thinking to compress my data,
how much data do you have, right? Because if you're running a controller bed, let's say 50 hertz, you said something about 10,000 bytes per second, right? That means you can do 200 bytes every iteration of the control loop.
Yeah.
I mean,
Well,
unless you have again something like LiDAR or a camera, what do you need 200 bytes for?
right. I mean, I'm not really doing feedback. Feedback, like I was gonna use 20 hertz, but now I was looking at the encoder interrupt, and it came in like every 600 microseconds. And
But you wouldn't be transferring that back to your powerful host computer every time you get a new encoder interrupt, right? You don't have to transmit every map. That's not going to work. That's not going to work.
It's not necessary, but
you want to
that was
communicate straight.
So I set out. I was gonna transfer all the data out, and I was gonna see what the interrupt is doing. So yeah, I mean I got there, but on the way I was stuck with this bandwidth. But now I see it. I don't need it anymore. So I can go back to my own baud rate. It'll probably be fine. But yeah, it's just interesting. I can set the baud rate like a million. So, and it just worked. I didn't do anything, just set the number.
I have an anecdote that's maybe applicable to this. When I was building a balancing robot, basically I used a serial link between the IMU and the processor. And what I found was that now balancing robots very different than any of the things we're talking about right now. But the latency introduced by the buffering of the serial link was sufficient to introduce the technical term for balancing robot is woogity. It became woogity. It looked like it was drunk. The samples were too delayed in time. And I actually had to go in and remove the serial buffering and go straight to the interrupt and process the signal straight off the interrupt. And when I did that problem went away. It's sometimes inside these complicated control loops that we're running that have a whole lot of things going on, Kalman filters and other things that eat up their own time. Latency problems can become very hard to track down. In a more common case, you might see that when the robot approaches an obstacle and it clears the obstacle, but because there's latency in that signal, it doesn't know that it's cleared the obstacle, and so its reactions are late. Once again, it's like it's drunk. It doesn't turn quick enough when it sees the obstacle, and it doesn't recover quick enough when the obstacle goes away. There's not just latencies in the comm link, although there are other latencies too in the control loop itself. But I just stick that in that the absolute speed of to the point I think Chris was making, the absolute speed may not be what you're ultimately constrained by, rather than the latency of the signal itself.
Yeah, there's a similar latency problem when I use Google Maps sometimes, because you get in well, that's not showing you all. You get in one of these places where the cell network is kind of slow, and Maps doesn't know where you really are, so it tells you to turn about 5 blocks after you were supposed to turn because of the latency.
I think that's built into
darn lag. It's always getting in the way.
TomTom was notorious for that. You pass the turn, and then it would say, "Oh, you have to turn here."
Yeah, turn back.
Yes.
Yeah, the minutes of latency is unacceptable for control.
Yeah.
It's like you're controlling something on the moon or somewhere. No, maybe Mars.
And then in classic, control loop theory, delay acts as like an integrator, and you can have instability. Remember that from control theory? Maybe.
Sure.
No.
Not just instabilities, but can fall into positive feedbacks where things go on real fast.
Yeah.
My old GPS, you could choose which language and what gender you wanted the speaker to be, and after trying a whole lot of them, I settled on the female French, because when you missed a turn, she sounded pouty.
Nice.
Howdy French navigation unit. Oh, that's crazy. All right. Hey, so we have Jack here tonight, being very quiet, and I want to make sure we get him before he sneaks out on us. Jack, you there? You got something to share this week? I see you're unmuted.
Why only 7 photons? Why not 8?
Can I go after Jack?
Hello? Calling Jack.
Are you there?
Jack, audio not working. You're unmuted with 3 green dots, but no sound.
I just figured out the reason I'm getting 2 of everybody that's speaking, like me right now, is because Harold is not showing us himself. He's showing us his screen.
Yes, David. Harold is very graciously recording this for us since Google stopped being nice and giving it to us for free.
Google stopped being nice?
I should have warned you to fasten your seatbelt before saying that, but
Hold the presses. Breaking news.
yeah. Okay, so Jack, if you get your speak up, if you get your mic working and such. Let's see. So how about Ray? Have you had anything for this last week?
Hello?
Yeah.
Oh, Jack's back.
Oh,
that's
is that
okay.
working?
Now it's working.
Oh, okay.
Hold that thought, Ray. What do you got, Jack?
Well, unfortunately, I haven't gotten too much done yet since the month or 2 ago that I was talking to you guys, but I did narrow down my problem with the power stuff, and the power supply was still providing a lot of power for some reason after I turned it off. So I'm not sure, but what I'm thinking I'm going to do now is I'm going to take a switch and I'm going to, get a new switch, and when I turn it off, I thought I'd have it connect the positive and negative. So that kind of, so then...
No.
Yeah, so then any charge still left on there.
No.
Okay, that was the only idea I could come up with, but...
How much do you like
This charge resistor.
No. You just need a resistor. You just need a big old fat resistor.
Do that through a resistor such that basically what you're doing is you're draining the output caps on the power supply when you switch it off. You don't want to short the 2 straight together.
That whole divide by 0 thing when the vehicle's IR thing comes into play. Yeah, you don't want that.
All right. I'm glad I didn't do that.
I like smoke and sparks. That's more fun. More funner.
Your switch shut or welded in that position. Good job.
Okay, so you guys are advocating, you're right, you're advocating a bleed down resistor or something like that. So what would you recommend for Jack? What is this, 5 or 12 volts, Jack? 5?
12 volts.
12 volts? So who can recommend a bleed down thing for the 12 volts?
Depends on the wattage.
It depends on how many amps you're pushing.
I think it's like 2.2 milliamps. I can't remember.
Well, but it's really the question is the output caps, right?
Yep.
Yeah.
So 12 volts, and whatever resistor you put on there is going to just heat up and burn energy when it's normally running anyhow. So you want enough to drain it down, but not so much that half your energy goes into the resistor.
Yeah.
So you want to calculate watts, right? So it's power equals VI. So if you got a 5 amp times 12 volts coming out of there, what is that? 5 times 12? What is that? 60 watts?
Yeah.
So you need a resistor to be able to handle 60 watts. No. You don't want to.
Well, you don't want 60 watt resistor, but that's
just trying to capacitors.
Yeah, that works too.
How about an oily rag?
How about a screwdriver?
Murray showed up. Murray, you missed it.
The reason they're giving you so much trouble is that the truth is probably stick in there will work.
Okay.
Grab a candy 1K or something like that.
Yeah.
Something that won't pull the the power supply down too much while it's running.
Yeah, but you're gonna need something bigger than a quarter-watt resistor.
It's
You need-
into the path to discharge those.
Yeah.
When you power.
I'm
Just-
confused where
Just
my
make sure the wattage on the resistor can support 12 volts
all right.
Yeah.
without.
Yeah, you're gonna need something more than your quarter-watt resistor you probably have laying around the house, I would suggest.
Okay. I'm confused where my logic went wrong with shorting it once it's turned off. I know it sounds awful, but I'm still a little
Well,
confused on
I
that.
think the thought was that it can be hard on the output of the power supply.
Okay.
But the other thing is that, like, if you have accidentally left the power supply turned on and then you flip your switch to short the outputs, that can be really hard on the power supply. Unless it's designed for driving out short-circuited outputs, which some are.
Well, I mean, I wasn't going to connect the battery terminals together. I was going to connect the circuit on my robot together after it's disconnected.
That's probably all right.
What?
Oh,
Well, that's probably all right, but I'd still put a resistor in there.
All right.
the thing with the resistor is you don't have to think about it. It's just always there.
That's true.
Yeah.
Okay.
You got enough to think about.
You know, Jack, the other end of that equation is true also. You switch that supply on, there'll be huge inrush of current into those output caps until they're charged.
Okay.
So that you get you get this huge spike of current that's very, very short. Just when you and so you need to think a little bit, ensure that resistor doesn't affect. You don't want a long on ramp.
Okay. Okay.
I don't think you can get in any trouble by just substituting in some different values and trying.
Yeah. All
The
right.
worst that'll happen is that they show you that they're actually fuses in disguise. Just don't hold them with your delicate fingers when you try this out.
So really, that's your best sensor right there. You know, hook it up and touch it. If it's warm, it's too small.
Mm-hmm.
And then that can enable your safe cracking later on because you won't leave fingerprints. Well, cool. Well, that's progress, Jack. I mean, we'll hand it to you. You've got school going on too, right? So
Yeah.
Yeah.
I'm
gotta feel good
curious,
about that.
do any of you guys know what happened to Steve? He hasn't been on here for a long time, has he?
Steve Edwards. So I mean, he's last I heard, he's got some family stuff and a kind of a high-end heavy-duty hobby thing that's distracting him right now. So.
Oh, okay.
And I think, at least at the start of the COVID thing too, with Microsoft, and their infrastructure was taking quite a heavy load from the COVID work from home stuff. So there was a lot of, and it sounds like he was spending all his free time interviewing and such too. So he's still around. We see him on the monthlies a little bit. I'm sure we'll see him back. But
The monthlies.
if we could get together in person, I think he's still up to host us at his spread for a
Okay. Oh yeah, that was
contest of some
last
kind.
year.
Yeah.
Yeah. Hopefully with this new vaccine, we'll be able to get back together again.
Yeah.
Mhm.
Next year, maybe.
Yeah, sometime later next year.
I am not an anti-vaxxer, but I will not be at the front of this particular vaccination line. I will tell you that now.
Yeah.
But when that happens, what happens to Chris and what happens to Murray?
Yeah, so we're gonna have to find a way to make this work for everybody, even the mix of physical and virtual. So
I have to tell you that I have found these online RBNOs much more valuable than the in-person ones. I find them better organized. We get more information. I think all the way around, I find it an improvement.
Let's continue it then.
Yeah.
I think we'd have to go back to the Google video thing, though.
There's always
Working around that now, so.
Yeah, the real time is more. I mean, I don't know who go back and watch the videos.
You'd be surprised. Go to the clips. I mean, there's some of these have.
I went back to see Carl and all his weird get-ups, so I could show Pam. You know, she could care less about this robot stuff. He liked the get-ups.
No, but some of these get 20 and 30 views. It's surprising. So
I just
Well,
think that
when I was trying again, saw some of them to see if I wanted to be in the club, and it got me interested in doing it.
as I say, we've added some new, really valuable members, 2 great robot builders that are nowhere near Dallas, and it would be a shame to lose them.
Yeah.
no, I hope that we can ensure that we're going to keep Chris and Murray at least.
Well, maybe we get together and build a remote robot bot thing.
Yeah.
You know, the remote presence robot.
Yeah. I mean, this club's been around since 1984, and nobody's done a telepresence yet.
Yeah.
Yeah. I think all the officers should have GoPros mounted on their head.
Oh yes. And that's why I'm voting for you next year, Ray.
Oh.
Yeah, but Carl, you've got that nice smooth head there. They'll just stick right on, and it's easy to,
Get the suction cup going.
yeah.
Do that if you want it.
Nice.
Before my battery runs down, I'm wondering if I can show something off.
Yeah, stereo.
Before my battery runs down, I was wondering if I could show something off.
Harold, what you got? Please jump in.
Okay, here we go. I'm now transitioning over to this.
It's on the floor.
It is.
It's not the bench anymore. Whoa.
That's
It drives like a pig in the mud, man.
Got a little lag.
Not the lag. What happens is the tires that are on there have almost no grip whatsoever.
Ah.
It's fairly heavy, and the ball bearing on the tail dragger is so rough that literally the tires do everything they possibly can to break loose the friction, and when they break it loose, it will go forward a little bit, and that kind of thing. And that's me
Do you have to
controlling.
weight more on the tires or the ball bearing?
I think I've got a couple solutions. One, most of the weight is in the middle of this thing, with the battery. And it's a little forward so that there is more weight on the tires than there is on the ball bearing at the back. However, the tires themselves are a little slick. The floor that I'm on is just a little bit slick, but I thought we'd get more grip. The ball bearing, though, if you just move it with your fingers without any weight on it or whatever, you can feel it being rough and just barely moving well at all. So I think.
Hey, Harold.
What now?
Harold, I had a prototype robot. I was trying to do a differential robot using those same wheels that I had on my main robot, and I went down to the what's it called? The Emporium. Anyway, they sell everything, and I managed to find a caster thing. I drilled it out and I mounted. I don't know if you can see this, but I mounted my robot wheel on it. And that would be what I would recommend is just if you're getting a robot that's as heavy as yours, just get away from those ball casters and get yourself onto another wheel.
Yep, and that's what I started looking at. I started looking at what I can get from AliExpress. And then and I'm looking at some of those and I'm like, well, I need some bigger drive wheels to make that happen. That's fine. Which ones can I get? All those sorts of things. And I'm thinking what I'm possibly going to do is roll down to Harbor Freight and see what I can get there for caster wheels on the back side of that thing, and see if there's somewhere there I can get some kind of wheel that I can put some kind of drive socket into. If I get some of those real, like the wheels you were just showing, if I can get one of those and get some kind of hub where I can mount that hub in there, so I can drive it, I think those would be great.
Check out the
It also
Detector.
looks like you're not ramping up your
on their own.
Check out Home Depot. Home Depot has bunches of those casters.
Yep, and
Yeah.
that's exactly where I'm gonna go.
Hardware, Elliot's hardware.
David,
You're from different sizes here.
David Anderson, can you hold yours up again? Because that looks like a super high-end RC plane thing.
Wow.
Is that what that is?
I would say, no, I built this. Harold,
Yes, sir.
if you happen to have a room full of machine tools, which you appear to have,
All my tools are woodworking tools, so I don't have all of those tools in there like that. So
You can have the first robot with the wooden wheel.
But if you've got woodworking tools, you could make it out of Delrin plastic or some kind of hard plastic.
Yeah, might do that. And Ray, I'm looking exactly those at your kind of wheels you're just holding up, Ray.
Yeah.
this is
The hardware store.
Yeah.
this is a radio controlled airplane wheel, solid rubber wheel, and those are Delrin.
Got it.
With a couple of ball bearings in here, and then there's 2 ball bearings on the shaft.
Yeah. So I'm looking at that.
The problem I found with those store-bought casters is that they wiggle. They're not very. There's not enough ball bearings, and the joint is not tight enough. So what you really need is a thrust bearing. So that there's no play at all.
That ball bearing thing they have is probably good enough for running around and doing something. They say it supports a good amount of weight, and it'd be okay if I'm pushing it and I can bear down and kind of shimmy it along a little bit. But the robot's not going to be able to do that. It's just not. It's going to need something way smoother. So that's my next thing. The other thing I've been playing on, and I don't have it all put together to show you, but I can show you the overhead real fast, and then I'll be done, I think. Overhead, me in the close-up. All right. So I turn the close-up thing around. I've got, maybe you've seen this mask thing before, right?
It's like the anonymous mask.
It's the anonymous, well, something like that. Put it in there. I've got the Adafruit. They call it a bonnet, an eye bonnet board, and it's got a whole bunch of connectors on it. And so I was sorting those things up for doing various things. This thing slaps right on a Raspberry Pi. Slaps right on a Raspberry Pi, and connects up directly between these rows of pins here, depending on whether you got an OLED or a TFT, which is what I have here. And I've got 2 of these. I'll give you a little close up and an overview here. What you're hearing in the background is I'm printing 2 of these things with holes in them so that I can glue them into this mask here. And the eyeballs here scared the shit out of my wife when she walked in the dark garage and I had them at a little demonstration going on an HDMI screen. This big screen here, 2 big eyeballs in the dark, just kind of looking at you with the things going on. It's crazy. And so if I can, I've got some stuff here. Make sure. Come on. Yeah. Desktop time.
Every day at Harold's house is Halloween.
Something like that. I mean, this is what they're really selling them for, but I got them because I wanted to do other stuff with it. And basically those what they...
You're right.
Yeah, that's exactly right. And if I can find a little video around here of them, they're just creepy as all get out, man. I'm just... yeah, let's see. Is that the eye bonnet kit? Yeah. There you go. So that thing there was running on a 1920 by 1080 screen in the dark with Toto's eyes thing as she walked in there and saw them going, and kind of freaked her out a bit, if you can imagine. So that's what's going to go into this thing. And I went after I got the robot actually moving and realized I've got mechanical issues and I need to figure those things out. I decided to take a break and on my Twitch feed and put together some of these things that have been laying around the lab a time or two. And who knows, this may eventually wind up on a robot or two, looking around doing something. Just, I don't know. They give you some ideas. This is all Python based on the back of it. So they tell you, here's where the graphic for the iris is. And of course they call it some special name that's actually means anything to an eyeball. And here's where the white part of the eyeball actually is, even though it's not mostly white. And so you can do, they've got cat eyes and reptile eyes and a few other things that people have done out there. You can do your own eyes and put them up there. And I'm like, okay, we might have to play with this in a little bit. I thought it was kind of fun. I thought it was kind of fun.
Isn't that Uncanny Valley?
Do what now?
Isn't that called Uncanny Valley?
I'm not getting a reference on that, man. I know I probably should. But...
Oh, it's, basically things that replicate human behavior, or you could easily be fooled to think it is a human.
Yeah. I got you. Well, what's on this board? I'll just show you the kind of the board here that they've already got it programmed up for you. You see these rows of pins here? This is for power, but this is input. So you do things like you can put a joystick in there on 0 and 1 and then control the eyes themselves by giving inputs to it. You can do another thing where make them blink. Right now they're blinking all by themselves and randomly. And then the other one is, I forget what, and the other one is iris. So you can make the iris expand or not. And they got some examples in their learn stuff to using like distance and some PIR stuff to and light detection stuff to make the eyes shrink and grow. And in their little bit of Python code that they give. Of course, you can get in a code and whack it yourself if you want to. But anyway, I thought it was put together. I thought it was kind of neat. And so that's kind of what I've been doing. So I will relinquish my time back to the court or whatever that is.
That's cool.
And that kind of thing.
One comment, Harold. It looked like, we were saying your wheels were slipping way too much. I think part of the reason may be because it looks like you're going from 0 to 100 in an instant, but you're not ramping up the speed. So that may be part of it.
Part of it is true. You're exactly right about that. The wheels. I can go slower, and I was not trying to be cool about that this time. But yes, there's a ramp up that I don't have in place, and you're right on that. Also, the wheels themselves though are really, really slick. They're barely grabbing on anything, unless I put just a ton of force on them. Even with my hands, I can do. They're pretty grabby, but I've got to put a ton of force squeezing them to get that going. They just don't do a very good job of that. Combined,
is there some chemical you can put on the rubber to kind of soften?
There may be. I hadn't thought about that. Maybe I just jack that ball bearing full of a bunch of white lithium grease or something, so it don't really matter what's on it, and put do something to the rubber on those things to make it extra sticky. See what's going on.
What do they do for drag races? Was it chlorine bleach or something?
Something like that.
That
reminds me.
One James Bond movie, they were showing how the guy did the jump, and since he had to nail it in this really narrow little rickety Italian stone-covered thing, what they did to make it more of a sticky landing was that they said something about getting 8,000 bottles of Coca-Cola.
Yeah.
And they let it dry off, and that was all it took for him to stick the landing.
The landing.
So they said the benefit was that after it rained, then it actually cleaned things up pretty nicely.
I ran across something on the Twitch stream this last weekend when I was doing other stuff. Is this cat out of California, and they said there was somewhere in Texas too, but basically have some storage units, and they were doing battle bots. Now we got the battle bots of the big ones and the big heavy ones, but their biggest ones were very medium sized, but those weren't as interesting as the tiny battle bot battles. They're kind of like the killer wasp. These things were about this big with little rotators on front of them. If you ever seen the Transformers, the first movie where they put the Nokia phone into the box and it jumps up and shoots around and tries to shoot all things. That's what they kind of look like running around busting. And basically they've probably got an 8-foot arena in plexiglass inside of a storage container, a storage unit. And that's where they hold their contest at, running around doing stuff. They're just RC bots, but I thought it was fun to watch a little bit. It was fun to watch a little bit. Not that we need to be attacking each other's robot. We do. It's hard enough to get them to drive on the road, let alone try to attack each other. You know. But anyway, it was fun to watch. Yep, and I'm out. I think I've said all I can. I mean, I can always say more, but you know, that kind of thing.
Hey, Mr. Ray, so how about you?
Well, I've been working on things mechanical again. I have, well, I don't know, I guess a little bit of electronics. I had one of the Gerbil boards. It's just an Uno with Gerbil software on it. And I was able to use, to drive an XY table with it to be able to drill holes quickly and easily. And then I thought, well, I have this ramps board with, the ramps boards have SD sockets on them. And so instead of dragging my laptop over to the setup in the garage, I could just bring over an SD card and plug it into that. And the things didn't work quite as well. There's a ton of settings in the CNC stuff, everything from setting velocities, accelerations, maximum speeds when you're just jogging, the number of micro steps, per millimeter of movement, all that kind of stuff. And I played around with those a little bit, but it's still driving the steppers that I have on that too fast. They're called slow syn steppers, and I think they're the fastest that you can run them at is like 60 hertz, waveform to get them to do individual single steps or, just single step. So I think if I, instead of doing fast moves without a feed rate, I think I can put in a feed rate and get them to move slower and not lose steps, basically. So I've been playing around with that. The slow syn steppers, they're much bigger. It's not like an U17. It's, I don't know, about the size of, not a coffee can. I don't know, maybe 3.5 inches in diameter and 5 inches long or so. So it's a stepper motor that's about that size. I was using the TB6600 drives, which are supposed to be able to handle the current. But from what I understand, you can't, people had issues at trying to drive stepper motors at faster speed. So at this point, I'm not certain if it's the TB6600s or the fact that I have slow syn steppers, probably a combination of both. But so I've kind of gone down that rabbit hole to try to get that all to work. That's all I've been working on. Doing a bunch of honeydews from my wife, so digging into robot time.
Nice. At least you had some robot time in there. That's good.
Yeah.
So let's see. Hey, so Murray, how about New Zealand? What's been going on there?
Well, let's see now. As I think you've been hearing from me over the last week or so, or last several weeks, is that whole thing about a Java programmer trying to program in Python is problematic when it comes to threading. And so I've been trying to rewrite my OS to better use threads because I can't get rid of threads entirely. But I've ended up in the middle of all this and I'm making very little progress. Right now I've got that integrated front sensor, which has got 5 infrared sensors and 3 bumper switches. And just getting it to pull that really quickly in a way that doesn't prioritize any of the particular infrareds over another, and because of the way you're calling. If you call, let's say, for example, in a certain order, it'll prioritize the one that gets called first. All this kind of stuff. Anyway, I won't go into the details. It's kind of mucky. But I'm kind of in the middle of all that, and I haven't had much luck lately getting it to run. So I'm effectively just in programming hell. Trying to think if there's anything else going on. Oh, I was going to ask if anybody has got any experience. There's a Swedish company called Aconir, and they make small radar boards, and they're like $20. Is the cheapest one. They go up to like about $180 or something. But they're a small board that is SP. I think they're not at I2C, but they're SPI based, and they have a range of 1 meter to 10 meters or something like that. And you've got 2 options on 40 or 80 degrees on the spread. Anybody here have any experience with any of these?
No.
Well, I contacted them via email, and they do have a Python library for some of it, and they've got an SDK and all that goes with it. And for $20, I thought I might buy the cheap one and try it out, see how it works, because obviously it's not a LiDAR. It does go through walls, so I can detect my cat in another room. Although, Doug has bought something. What do you got, Doug?
These are, I can't read the numbers, but RCWL 0516s. It's a radar motion sensor, and I'm not sure what you're wanting to do with the radar, but I'm wanting to use it for detecting if somebody's walking around my robot. But I was hoping there could be some other information too.
I did buy one of these little $5 ones that is it's I think a radar motion detector, and I used it for about a week and it burned out, and I contacted the Chinese company and they were sort of like, well, it's $5, it's your problem.
Yeah.
So
I got a whole bunch of these for not very much money from Amazon.
That's literally what the guy said to me, and it's sort of like, why don't you just buy another one? It's like, no, I'm not going to buy another one. So no, I was thinking about motion detector, but actually this is a distance detector.
Right.
And so I thought, I have no idea how you do it, actually. It's just kind of a curiosity for $20. And because it's SPI and not I2C, I'd have to rewire part of my robot to get the SPI bus working with this particular thing, and probably write a fair bit of software, because there is a Python library, but it doesn't sound like it's really tailored for robots. I think they use these things for like in water tanks to measure the depth and things like that. You shoot down onto the water and you get a distance. So in any case, it was just curiosity. It's called Aconir, ACCONEER, Swedish company.
Well, find out. I'd be interested in learning more about those myself.
They sell them on robotshop.com, the Canadian company. They've got about, if you go to robotshop.com, there's about, I think, 3 or 4 or 5 models of these things in various prices, from $20 up to like $170 or $180. And the one that I'm looking at, I think, well, the more expensive one that's not the most expensive has a little radar board that's maybe the size of a postage stamp that fits onto a carrier board, and on the carrier board you get your interfaces. So and there's some Swedish guy with a really perfect haircut doing a demo on a YouTube video. So yeah.
Hey, have you heard of Andrea Spies? He does a ton of videos on electronic stuff. I know he reviewed a bunch of the radar detectors. I don't know if the company that you mentioned was in that or not, but yeah, and I remember from one of his videos, he had a friend of his stand, I guess, on the other side of a glass wall and detect, that he was there, basically. I don't know if they were more distance sensors than like human presence sensors. So,
well, the one that I did have that was a motion detector, that cheap one that burned out, worked pretty well. It actually, you could, if you aimed it at a wall and then had someone move on the other side of the wall, you could detect motion. So that's sort of what Doug's talking about. And that did work, although I'd have to find a different, either just buy a few of them and assume that they're going to burn or something. But I was thinking more distance, but I have no idea how a radar sensor works when you aim it at a wall. Is it going to detect the wall or the person or what? It's kind of, I don't really know how they would actually, but it's.
I think it actually, even being made of mostly water, I think we're good reflectors for radar waves.
Well, and there is an SDK with a little visualizer, so maybe it actually shows like, a radar image that you can see the wall and see the person and see the cat and whatever else. I don't know. No idea. Curiosity, like I said.
Yeah.
I don't know if it's the same thing, but I do know from some of the people we work with that there are devices that they put on wellheads to shoot down the pipe and show what the level is down there. And I believe those are radar. I think that's what that's for.
Yeah, and I had that's exactly it. And some of the use cases that Akineer show on their website are precisely that, for like inside of tanks and things.
Oh, yeah.
Okay, and of course, they use ultrasonics for that as well, and ultrasonics would work just fine. But so it's, like I said, it's kind of a curiosity to think what you would use a radar on a small robot for, because it's going to see everything in front of it. So how do you interpret that data? I have no idea.
Check out the speed of other robots, mate.
That's a different kind of radar sensor. There's they have those as well, the speed sensors. Apparently, you can get either. This sounds like a PID loop question.
Hey, cut it out, cut it out, cut it out.
It's either distance or speed. I don't think you can do both with the same sensor, as far as I can tell.
Well, David's got those Panasonics on his robot, right? That's radar, isn't it?
No, those are ultrasonics.
Oh, okay.
Remember the old cameras back in the 70s with that kind of gold foil thing on the front? That's one of those.
That's ultrasound.
Yep.
Right.
I still remember, when I got started in all this, before all this robotic stuff was so cheap, right? I had to buy old Polaroid cameras on eBay, right, to get to those sensors. I don't remember how much they were, but they were not cheap.
But they're high end.
Like $100, weren't they? David will know.
Something like that.
Got Polaroid sensors, David?
Yeah, the company SenseComp, SENSCOMP, bought all that from Polaroid, and they continue to manufacture and sell them. I will say I've used a bunch of those, and I've used a bunch of the little cheap ultrasonics, $12 a bag sensors in to the point that Chris made earlier, which was that it can see his cat. I found those little cheap ones. I use one on the balancing robot, and it's useful for some things. But the SenseComp, those old Polaroid sensors, they're so much more powerful. So for my outdoor robot, for example, they can see foliage. They can see chain link fences, which the little ones can't see at all. They're just a whole, and they can see out to about 32 feet. Actually, it's advertised at 32 feet. I've never seen one get more than about 20. But for a robot this big around, what are you going to do with information about what's 20 feet away? What use is that information? At any rate, as I say, I've used both, but and it's more complicated to use the Polaroid. They require a little more shucking and jiving. But I've had very good success with those, and they're not subject to those other problems that Chris described.
And they have very specific power requirements too, right? I remember in the old days you had to use a special lithium polymer battery. I mean, before they were popular, those batteries, right? I mean, they suck a ton of power when they pulse, right?
They do. Yeah. They do. That's the trade-off for getting, for being able to see chain link fences. Yeah. If you put your finger across the terminals, when it pings, you'll know it. Substantial.
Don't do that often.
Yeah, I thought it was like a 2 amp spike on, it's like down in the milliamps, and then boom, you get the 2 amps.
Yeah, and very high voltage too. I mean, like, I don't know, 200 volts or something, right? I mean, it's
200 volts. There's a little buck boost onboard circuit that generates that from a little coil. Yeah. But as I say, in terms of functionality, I've been pleased with it. The other problem Chris described, which has to do with getting specular reflections and multiple reflections, that problem doesn't go away. However, I have found as a practical matter that those tend to be transient. That is, when you scan along a wall, you'll get pretty good readings, and then there'll be transients where you get these sudden long echoes. And depending on how your robot software is written, transients don't have much control over what the robot does. That is, in order to turn away from a wall, you have to see that wall multiple times, not just one. And so, in a practical sense, those transient reflections can be handled. Now, I have specific cases. For example, when my little indoor robot, which uses the same sensors, goes under my desk, which is metal, and you have now corner reflectors in all directions. Basically, at that point, now you understand the reason in subsumption why the infrared takes over and subsumes the sonar, because under there the sonar is just totally confused. It can't make any sense at all. Looking straight into the corners, and it's very confusing. So that problem doesn't go away. Whereas with infrared or LiDAR or something, you don't really have that. Although you do have that with mirrors. That is, infrared and LiDAR give you the same problem with mirrors. You give back returns that say that mirror is not 4 feet away, it's 8 feet away. So I'm through complaining, that's all.
That's cool.
You have a vain robot. It shouldn't be looking at itself.
Okay, guys, I'm going to sneak in real fast this time and then hand it over to Ron. We got to get him moving on. So, but before that, I have something you want to see, Ron. So I'm going to start off with this. I think everyone's seen this guy before, right? The little mechanical wheel thing. So just know that there's the reason I'm showing this first, and it's because the fun name for this, the project name for this is called Hover Sim, because I'm using it to simulate the motion of a hovercraft. Okay, so now that you've seen Hover Sim, I'm going to share my screen, which is this one over here, and I'm going to show you. I'm going to introduce something that I now call, you see the title? Hover Sim Sim. So this is Hover Sim Sim, and I wanted to show I've got some progress here.
He looks hungry.
Look at this.
He looks hungry to me. I'm just saying.
Does look hungry. It's a trashy robot.
Looks like something out of Monty Python.
You know? But it follows along pretty well, really. Now it's only handling the black on white, but you can grab it and it'll find its way, whatever.
So
Great. So you're moving sideways and rotating. Okay.
Yeah, sideways and rotating.
Oh, okay.
Well, so sometimes you got to get it close. So anyhow, I'm pretty happy with it because it's at least, and this is, by the way, this is using the same simple detector that the simple bot uses. So it's really, anyhow, making progress. So next now I have to go and do some things to make it work on the challenge course. But I just wanted to steal that thunder because whatever good this is showing, I think Ron's going to blow me away here in just a moment. But anyhow, so Hover Sim Sim. Hello, Hover Sim.
Very good.
Very good.
That's my progress for the week, and I'm sticking with it. What did I think? Okay. Anyhow, so that's it. I'm done. So Ron, how about in your world now? I think you've been a busy boy, judging from that mail you sent to the Obama committee.
Yeah, there's not much of me left. So yeah, I've been working on the time warp acceleration, whatever you want to call it. For those who hadn't heard, I was hung up on rendering a frame and then processing a frame, using the GPU to render a frame, and then I would transfer data from the GPU and analyze it. And, I was sitting there trying to speed the thing up when I realized the processing we're doing isn't that much on the, for the simulation. So I decided to scrap the GPU and just do everything with the CPU, except occasionally every 30 or 60 times a second or whatever, go ahead and repaint the frame, but do lots of intermediate simulation steps. And I guess I'll take over and I guess I'll talk a little more this weekend. I won't talk much now, but I'll just kind of highlight what I've been working on. So hopefully, try to look at the time so I don't talk for half an hour here. Let's see. And I don't know how well this will work on the screen capture. Does the screen look kind of, can you tell that there's some undulation in that path that you're seeing?
Yep.
Okay, so what you're seeing is this is the time warp. And so we're running, right now I'm running 10,000 steps per second. So previously that would require 10,000 frames per second, which is not realizable. I could maybe do 500 with a good GPU. So the cool thing is you're seeing a line following robot, in fact, a very simplistic one, run the entire course a couple frames a second, I think, roughly. And I could probably make it go faster, but I have a step of about a 60th of a second, and you're seeing the laps tick off there at the bottom. And the cool thing here is you're seeing an entire course run in half a second. So when you turn your knobs, you get to see the behavior or the path following behavior instantaneously that you would wait or let's see, these laps are 60 seconds apiece with this robot. So you can wait 60 seconds for a lap or have it done in under a second. So let's tune it a little bit. I'll bring up a parameter menu. And by the way, this is a very simple line following controller. I wrote this one for Kareem because he said his kids sort of understood the idea of a left motor, right motor, kind of on or off sort of thing. And I think this controller, it's about 3 lines of code. I think I have a couple different speeds. I think I have, oh yeah, so you can see here a speed in the clear. When neither sensor is detecting the line, it'll go one speed, and then there's speeds that when it's turning, when one detector hits the line, sort of thing. So anyway, let me go ahead and turn some knobs. Oh, by the way, let's see. So I turned the opacity down of the robot because it drives you nuts looking at it, and I can see the screen capture doesn't really faithfully catch. But the thing's just zipping around and zipping. But we don't really need to see that. And the same with the actual course that the robot's following. I added a dimming feature, and I think Kareem mentioned this, but my wife also got sick looking at the images. But anyway, so I don't know if this shows up. It doesn't look too bad on your display, but what I'm seeing is a strobing like blur. So that's actually really just a snapshot every roughly 60th or 100th of a second, I guess. But anyway, taking multiple simulation steps per draw, and if I turn it off there, that's normal speed. But in this case, we're running maybe about 100 steps per draw step. So bang, it really goes fast. Oh, and I have if somebody might recognize that time warp from Rocky Horror Picture Show. That's
it's just a step to the left.
Yeah, it's just a jump to the left. Anyway, let's turn a few knobs and look at this path.
Yes.
Okay, let me get back my parameter editor. So here we are. So now I can change, let's change our sensor separation so that dynamically I can change the sensor separation. And now we've got it out to about 4 inches, and you can see the path change before your eyes. And then, for example, let's crank our speed up. Oh, there it goes. It failed. So we can turn the knobs to see when the robot fails on the course. So this is immensely helpful. And I think now, although I'm kind of fried, I think I'll be able to get my robot really running well with this kind of technology. So anyway, it's available to everyone, and it's up on GitHub. So all you need to do is load processing, and I'd force you to download their sound library because I have sound effects now. I can't live without those. But anyway, so there's a simple line follower. And then I'll show you my line follower. So I'll go, and before I do that, I will show you the program that's running here. So just to give you an idea.
It's really cool. I mean, how better to tune your parameters than to watch the behavior across the whole course once a second?
Yeah, it's just awesome. I mean, talk about cool. Anyway.
Your big loop tuning right here, buddy, huh?
Yeah, that's it. So here's this, this controller for this robot. Is let's see, we've got a sensor left and sensor right, and those return values from 0 to 1. So here's the controller. It says if both left and right see white, then both motors run the clear path speed. And by the way, in fact, if the lap is greater than 2, I make the left motor run 10% faster than the right, simulating kind of a, a not a perfect robot. But anyway, and then we have our turns here, and this is all governed, of course, by the simulator's parameters, which we'll go ahead and we can come in here, help, and let's see. So here you can see, so this robot, although there's instantaneous demands for speeds, but everything is linearly slew rate controlled, so the max speed is 36 inches per second. Which we're running nowhere near that. I mean, even though we're accelerating the simulation, it's still taking a minute to drive around the course in robot time. But here are all our acceleration, deceleration rates. The turn, sorry, Chris noted it's pretty sluggish on the turn. A little pi line follower will beat this tremendously. But these are the current maximums, and these are what were set for the contest.
You're saying those numbers correspond to the simulated time?
Yes, yeah, the simulated time. Yeah, so every step is being faithfully taken. It's just we're not seeing them all, but every step is
velocity commands in inches per second, right?
Yeah.
So robot units are inches per second, and then the simulator just turns it up.
Well, what happens is because it doesn't take much time to analyze what the sensors see, and so I'm doing that now with the CPU versus GPU. So really, in an inner loop, we're only updating the screen maybe 60 times a second because, the computer is going to only update the monitor or whatever. Maybe it's 120 frames a second. I don't know what the maximums are on the typical display. Maybe some of them run faster. But anyway, I'm faithfully executing all the simulation steps so that it's identical to as if we had run without the time warp. In other words, without the time warp, although now I've got this thing double buffered. Let's see if I get rid of the loop. Let's see. A little hard pressed here. I'll tell you what, I'll have a demo, but let's see, where are my cookie crumbs? Wait a second. Let me stop the thing. Let me get the, hang on one sec. There's the robot. Hang on. Oh, here we go. Let's see. Let's try this. I added double buffering so the crumbs wouldn't flicker too much. Okay, here's normal speed. And so the robot's behaving exactly the same. It's just that when I speed it up, I'm just iterating the steps without you seeing them, but I'm doing everything the same. So there's no difference at all. Time warp, that's time warp. Not time warp, not time warp. So anyway.
Do you start off in the same position every time, or do you just start off where the robot is?
Oh, yeah, you can. Yeah, let's see. We got a kind of a mess here. Wait a minute. Let's make this a little brighter too.
And does that influence the next path that it takes if it doesn't start off exactly?
Oh, yeah, it probably would. If we dropped a marker here and then we said we wanted to start the robot here, it probably would, influence the behavior somewhat.
Okay.
Oops, okay, it drove, yeah, I need to loop it. Wait a minute, let's see. So there now it's, let me dim the course back. Let's see, hang on, dim course. It's actually looks like it's a different behavior, doesn't it?
Yeah.
And it's actually failing the course when it starts at that location, or had started at that location. So yeah, that's
okay.
But hopefully everything is correct. And as I play with my robot, I'll be verifying that I am in fact doing everything the right way. Anyway, doing it correctly. Oh, but of course the other thing too, a big deal with this is it's good to see things slow. So this is only one facet. Of course, the other facet is to slow the robot down and to, virtually like to where you're single stepping. And this is here single step. So you can, whoops, I don't know what's happening. Oh, the robot is way off kilter. Wait a minute. Anyway, there it's single stepping. Not too exciting though. Okay. Anyway, so that's that. I'll show you my robot that I was bragging about, and I guess I wasn't lying that I had completed not completed it, but I have an operational controller, and then I'll shut up. Let's see, I'll get rid of that.
Can you also show the switching of course? That feature hasn't been working for me for a couple of versions. It was working at some point.
Oh, okay. Yeah, so Control C with the, oh, and by the way, I did keep the key menu, so that the key menu is there, but and then Control G takes you back.
What I see happening is it's switching the course, but the thing on the top left is showing. It's showing. See what it's showing in the top left? It's not on top of the course.
Oh yeah. Ah. Oh, interesting. I haven't even looked. So obviously it can follow the course. Hang on, let's see if it's.
No, I don't think it's following the course. Well, maybe it is, but it's okay.
It is. Oh yeah, the view is goofed up. Wow, Chris. Thank you. Yeah, do bother to let me know when you see these stupid things. Interesting. Let's see what. Let's try. Let's see if it's. Okay, that view looks good. Oh, look, this view is goofed up. This view is, now this is the view, well, actually, the view where I'm actually sampling the sensors is not being rendered. But this does look good here, but that's goofed up, and I hadn't noticed it. Ah, I'll get that fixed. Yeah, sorry about that. But obviously, the robot sensing is correct for it to function, because if it was, it would be messing up on this. Oh, very good. Yeah, I didn't notice
You're not running the right course because it shows up the acute angle there in.
Oh, you're right.
Oh yeah.
Yes, it's the other course. Right there. Thank you, Dave. Okay. Yeah, boy. Wow. Interesting.
Showing the
Whoops. Oh. Anyway, yeah, okay, so let's go back to the fascinating.
The thing you're showing is the wrong course for the robot, but
the correct,
you're showing.
Yeah, okay, yeah, I'm showing this course. So it works okay on this.
Well, that's really weird because it's working correctly on mine. I have the version 9 library or 1.5, whatever that is.
Oh, now if you toggle through the courses, they look okay?
Yeah, it's showing it correct on.
It was working at some point, and then it stopped working. I don't remember what version broke it.
Huh. All right.
So yeah, anyway, so this is the, okay, I think this is be my robot running the actual contest. And so I'll do it, and I have a ticking stopwatch. Does the ticks come through?
Yeah.
Yeah.
And if you slow them down,
So let's look at the sensor arrangement. So you got one straight line sensor, two arcs. Okay, good to know. Good to know.
Yeah, Ron, does 2 curved lines help you in any way?
What's that?
Is that the
method? Well, I don't know. Maybe I'm not really using this. But anyway, so that's what I can run. Let's hope.
Carl, I have a question. If the simulation runs exactly the same when you run it at 100 speed as when you run it at normal speed, that's correct? But if you're doing all the same process.
Yes. You talked. Yeah.
So for the contest, why don't we just do it 100 times speed?
Well, yeah. I mean, so we don't have to sit here and be bored. Yeah. I mean, although it might be nice to not run it at 100x necessarily, but here, you certainly
can't you just enter your algorithm, press the button, poof, it tells you whether or not it worked.
Well, that's right. But yes, the fun is maybe to see the thing run the course rather than to see a blur. I mean, this might not be considered so fun.
We can finish the contest in 10 minutes that way. Boom, back to Saturday.
Yeah, just have it spit out the number, right? You press a button, it spits out the number,
Right.
We don't need any of the animations at all. You just enter it with the number.
Yeah, that's it.
And as a matter of fact, then you should be able to do that for both. And then for the contest, just send in your number.
Yeah, that's it. Yeah, so my number on this is I'm just under 5 minutes. Let's see. So
You gotta step up your game.
I know. Yeah, no kidding. But at least I'm getting through it. But yeah, I'm at 4 minutes and 59 and whatever it was seconds is my run. Well, here I can do it. I can do a let's see, run contest.
Yeah, I can't make it through the whole course yet.
But how did I do it in 344? That's not right. Oh, I must have cut it. Well, I cut a corner. Oh wait, wow. I didn't think I was able to do it that fast. Wait a minute. Maybe I've turned some knobs and I don't even know what Oh, I cranked my bit constant up and I think I'm able to run the course faster. Yeah, so I ran it in 344. Oh, but I screwed up right there.
Can you just run it to the first intersection? How long does it take you to the first intersection? Because that's point.
Hang on, let's see. Which this right here?
Yeah, E4. You have to stop it at E4 and let's see how long it takes to get to E4.
Oh, I think I have a thing I call go to the marker. Wait a minute, let's see. Let's test this. I just wrote this during the first part of the meeting. So right here, I'll put a marker. And let's see, and then if we run to that, I think it should work. So I'll say go to marker. Let's see, that. Let's see, this should work. Works okay. And go to marker. Okay, so a minute 20.
Yeah, you're gonna have to take a minute off there.
You got it in 20 seconds?
I have it in less than 20 seconds. I'm not like anything.
Okay. Chris, you suck. Okay. All right. Well, I figured I would not. I figured that I wouldn't get to win this contest. So, but anyway, what sits here is, I don't know, about 5,000 or more lines of code. So anyway, but really the simulation doesn't that much of the code. It's all the bells and whistles and garbage. But I do expect if you're going to compete to have like a cool starting sound, and cool, customize your sound effects maybe.
Actually, I'm having a hard time with E2. That gap, I know some earlier version of mine made it through by accident, but now I'm having a hard time getting over that gap.
Ron, I have kind of a feature question. I know it's a bit late in the game, but one of the things about simulations is that basically there's not really any drama. Like in BattleBot, your robot might get damaged. And I was thinking that what you might do is add a feature that, or maybe a requirement, that if the robot runs off the course, it erases the hard drive.
Yeah, there you go. I had the robot explode. That's an option. Is to explode a robot. Okay. But I guess maybe the robot could run off and overwrite some of the files on the hard drive. How's that?
Yeah, kind of randomly in your documents folder.
Okay.
Ooh. No mushroom cloud or anything. Huh?
Yeah. Anyway, okay, so that's that. And I guess there'll be a little bit more at the meeting, but I don't want to burn people out on this. Any questions or anything like that?
I had a question. If you start in using time warp, using any simulation or any mode, I guess, in the same place, shouldn't you just be retracing your steps over and over again? There shouldn't be any variability.
Right. Yeah. So you can turn time warp on or off, and it, provided I haven't made some little minor logical goof in the program. But I am going to be checking that a little bit. Earlier, Will's trike robot, I noticed there was some problems, but I think I've cleaned that up. And so I am going to look at that. I just, I've been trying to, get all the features that I thought were important in, and probably it was a waste of time. This GUI stuff doesn't really do much for the program, but it makes me happier, I guess. And so, stupid though. This is getting to the point where, custom writing GUI code versus find a good GUI to go with, that sort of thing. Yeah, stupid. Stupid is reinventing the wheel, stupidity, but anyway.
Ron, you've always been, as long as I've known you, you've always been so fast at cranking out really complex, sophisticated visuals and so forth, that I would be surprised if you hadn't done that. And I think you deserve you know, a nice fruit basket and a round of applause for all the work you did.
A nice fruit basket.
Or at least a round of applause.
Well, I am getting a reward. My brother's sending me a MakerBot 2X that he's tired of. So now I'll have 2 3D printers, even though they're old. And he's also sending me this little scanner that they made. It's some sort of video laser scanner. You can digitize your garden gnome, and I've got a garden gnome I need to digitize. So. Anyway, so I'm getting a present for my hard work. Anyway.
Oh my goodness.
So how long have you been making that garden gnome wait for digital?
Years. In fact, I could show you, actually 30. Let's see.
30 years. Oh my God.
But is it an animated garden gnome?
No, it's Pam's. This has been with her. Maybe it's older than that. I won't say anything about age. But he's a little garden gnome, and I think it's just the right size that I can digitize him. And that's what they show on this MakerBot digitizer. They digitize a garden gnome, a little tiny gnome. So I figured, perfect. That's all I want to use it for, and then I'm going to put it on eBay. Well, I don't know. I'm curious to know if one of those digitizers is good enough to digitize some random item to make it easier for me to, you know, custom model something. Like I made a holder for my phone. I'd love to be able to digitize the object and import that mesh, and then, you know, make the part that I need that's going to fit the mesh. But we'll see if that works. Anyway.
I'm assuming it's not like the Xbox 360, and you know you have somebody sit in a chair and have them slowly rotate around.
Right, it's a miniature version of that. I'm curious how good it is. It has a turntable, but I believe it has just video cameras. I guess what it has is probably the resolution sufficient to digitize something so that you could faithfully print it. And I don't know what that means. Maybe, what do you think, 1/10 of a millimeter precision or something like that, or 1/2 millimeter? Be interesting. It'd be interesting to know how linear it is. But you know what? I come to think of it, they have a correction. I've seen the cards now, and I didn't give it a thought, but they have little grids that they show the camera. So obviously they're correcting for camera lens, you know, being pushed, whatever you call it, barrel distortion and all that lens stuff. Yeah.
Ron, they have one of those at work. The dinosaur guys across the hall in their lab that they scan the dinosaur bones and then 3D print them so that they can hand those things out to study without damaging a 250 million year old fossil.
Oh, yeah, that's cool.
I think it works quite well. I mean, the replicas look almost identical to the.
Really? Oh, that's cool. Yeah. You know, I guess that is the thing they advertise, is you can scan things and then print a replica. And I suppose that's neat. I never really gave it much thought, though, as to the.
They brought the.
I got a molar.
The Lucy fossils. Do you know that ancient?
Yeah.
They brought Lucy fossils from Ethiopia, and they scanned those. And the whole time, you know, those are national treasures. So we, none of us were allowed to touch them. Only the guy who came with them could touch them. We had to make holders for them to go in, and it was accompanied the whole time by an armed guard.
Oh, wow. And then after you made the replicas, you couldn't tell the real ones from the originals.
Well, bone doesn't look like plastic.
Okay.
Oh, yeah.
Hey, but I got this new bone filament. Have you seen it?
Bone filament.
I'm just teasing. Anyway.
Hey guys, have to leave now, but I'll see you next week.
All right. We'll see you, John.
Bye. Good
night.
Good night.
Yeah, I think the Xbox, using the Xbox 360 and somebody rotating on a chair, it would never get like the top of your head. So when you 3D printed it, you have part of your head, but you know there's going to be a pretty good space on the top.
Oh yeah.
Which for some of us is still pretty accurate, but. All right. Hey, well, thanks a ton, Ron. All right. Let's
okay.
Hey, so Mr. Jean, very quiet tonight. How's it going there?
Okay. Speaking of 3D printers, I need to clear out my head. It got clogged, so I started to print the thing that goes together, however, like that, somehow. So it will look like that. So that's the top part.
Of what?
Of the robot. One robot I showed you all the other week or two back.
Huh, okay.
So this is part of the framework. The servos goes there, and the real leg goes like down there. So it's starting to do it. It's about 3 small parts to print. So that's 2 of the parts.
So I missed what that was, John.
It's going to be a walking robot. Basically, it has 8 servos, and then the legs are basically like this. So when one of the servos moves, it moves the legs. Pretty neat.
Cool.
Eventually, you'll see it once again, all the parts printed.
It sounds like a lot to put together, like that other walker that you did.
Yeah, similar to that, but yeah, it's somewhat similar in the sense of that leg. Yeah, where you get basically the angles move the legs type thing.
You need to scale it up to be like the Boston Dynamics spots. So.
Yeah, well, eventually it will. I mean, this uses those 9-ounce servos instead of the big ones. So, hence, to me, it's a little small. But start small, go big, right?
Much easier. Okay, cool. So see, Mr. Doug, also quiet. How's it going?
Doug P.
Very quiet.
Doug B?
Doug P. Doug here? Oh, sorry, Doug. Doug P. has his microphone on, or?
Oh.
Yeah, I'm just proud to be here, guys. Right now, I'm not getting too much done on robots, but I do hope to compete. So I got to get my butt in gears here sooner or later. So we'll just see how it goes.
Oh, cool.
I knew Ron wasn't finished.
This is software. It's never done. You got to just jump on the train and hold on tight.
Well, it's pretty good, but I guess that bug that Chris caught, that's worth a fix. It doesn't impact the functioning of the program, but look for that. I'll get that done in a day.
Yeah, I'm curious, Ron, if that was because you demoed switching the course while without a restart. I wonder if that had, otherwise, you're switching it in one window, but not in another window. I think you'll be able to fix that pretty quick.
Well, yeah. I'm surprised, though. We'll see. I mean, I'm loading the bitmap, and I thought I was referencing it all over the place, and there should only be one copy of it in memory, but something went amiss. So, I'll track it down. Well, no problem.
We're just a tough audience, that's all. Sorry, Ron.
No.
It's all a smop.
There you go.
That's right.
Smop. All right. Well, let's see. So I think pretty much everyone has spoken, but Chris, were you going to demo something, or have you?
No, I have not made really any noteworthy progress since last week. So nothing new to demo.
Okay.
Just so you could brag, 20 seconds to run about half the course.
Well, it's much less than half the course, but it's of no use if I get stuck there, right? I think I'm gonna have to slow down a little.
And until he shows us, do we really believe it, Ron, or is he just like playing the hustler?
But we've had this conversation of how closely do we have to follow the course. My green dots are not exactly on the black line, right? At the breakneck speed, I'm a little bit off the line.
Well, that's how it is. I think I'd like to see it not quite tracked. Besides, you're limited by the simulator. You must be running up against what it can physically deliver. I mean, you must be, I'm just speculating, you must be maxing out your velocities and your turn rates. And
Yep, absolutely. I'm running a breakneck speed.
For what it's worth, in the real physical contest, I think the convention was always that as long as the line was under the body of the robot, that you were considered to be spinning on the line. Well, of course, you just make a real big robot.
The problem is that there is no size to the robot technically. You know, it's just really a a forward velocity and a turn, well, target forward velocity and a target turn rate subject to accelerations. And really, there's no size to the robot, so it's not. There's no constraints really there. Now, I guess Kareem's model, I did have to add, separation between the wheels for it to realize the, for it to translate from wheel velocities to rotational speed and forward speed. But anyway, that's beside the point.
But you could argue that the sensors are only able to see an area that's, 12 inches by 12 inches, right?
Roughly, yeah.
And you could kind of say, well, you know what, no matter, yes, there is no actual size to the robot, but you could treat that as the size of the robot, right? You can't place a sensor outside of that area.
Right.
And, in those Fast and Furious movies, it's all about drift, remember? It's like how fast you skid around the corners. So if you're actually coming back into the line, even if you skid around it, and you get back on the line, man, that's cool.
And we all know that Mari is the holder of the definition of cool. Look at that hat he wears sometimes. I don't have it on now, but dude, I'm just saying.
Carl, I have something to demo.
Oh, cool, good. What you got?
All right.
Is it as cool as that hat, though, Dave?
Yeah, it's got to be.
Absolutely. It's more cool than the hat. Okay, well, I haven't done anything with robots in weeks. I did discover that the problem I had been chasing with the LCD display fundamentally turned out to be that I had outstripped the capabilities of the little power supply I was using as I added more and more functions. And so I was chasing this thing in software for several days. I even went and got a new LCD display thinking there was something wrong with it, and it behaved exactly the same way. So I got a new Volvier power supply, and all my problems went away. So just a warning. So here's what I did instead. In order to make this work, I've got to show it to you backwards. This is a little paper model. It's a dinosaur, all right? And you can't really see it, but if you move back and forth, and in this case, I'll have to move back and forth.
Mm-hmm.
The eyes. Wow.
I don't know. Yeah. Okay. If I turn it enough, you can see the illusion right there. But without that, it really looks like. I just think it's amazing.
Okay. I got a little brush with fame here, thanks to Doug, because I have met the guy, sat with him at 3 o'clock in the morning at Magic Convention, the guy that invented that thing. Andrews is his last name, and he's about as neat a fella as you could imagine too to hang out with. Yeah.
No, you just print it out and put together with Scotch tape, and you set it down on the table, and when you walk by it, it follows you with its eyes. And it'll follow you when you go up and down. It'll look up and down. It's just amazing, really. Okay, that's all.
So do you have a link for that? That's way too cool.
Yeah.
Let me see if I can find the link. I'll add it to the chat.
Yeah. That would be phenomenal.
Yeah, he was sitting back in like.
Do you have a link to it?
I do not have a link to it. It's been a long time since I've hung out with that gentleman. I'm sure he's passed away by now. But
what's the name? Andrews.
Andrews. I have to look it up. Let me see if I can go look it up real fast.
Wow.
He was on the show That's Incredible back in the late 70s, early 80s. You know that Escher Impossible box? He made one. He made one, and if you and as long as you view it from a certain perspective, the impossible box is a doable thing. It's just really cool. He was just sitting in a room with some water, and we were having conversations about how he did these things.
Just Google T-Rex illusion.
There it is on YouTube. How to make it. Very nice. Print your own. How to make. Cool. Cool. Very cool. All right.
They also have some other models that were puppy dogs and cats and stuff. None of them work as well as the dinosaur. The dinosaur works great.
Huh. That's worth the price of admission right there, folks. That's cool.
Yeah, it is.
Yeah, it ended up on Slate. They called it a brain melting illusion.
I knew something had happened.
Yeah, the rabbit looks really cool. I'm liking it.
Huh.
Yeah.
Just don't tell anybody else what we get up to around here, right?
That's a good thing there's no recordings of this. Cool. Hey, so
that is as cool as Murray's hat, isn't it?
Yes.
That's really ranked up.
Uh-oh, he's got a better hat. We're in trouble.
The dinosaur kind of reminds me of some of the Byzantine art. Yeah. Oh, weird.
Okay, you win.
We're allowed to wear these when we don't get shot.
So, I mean, there's got to be, is this based on some other knowledge, or did he invent the whole thing, sort of thing?
I do not know his full story. I do not know his full story.
We tried making one that was just geometric, and it didn't seem to work. And so I think that there's a psychological thing going on. I think because you want to believe that that head is pointed toward you, because it makes sense with the rest of the body. That you, when you hold a thing in your hand, what you find is that when you look at it with both eyes, it's obvious what's going on. When you close one eye, which is, of course, all you guys have here, and it immediately pops, even though you know it's pointed the other way. When you close one eye, it immediately pops the other direction. And I think at least part of it is psychological, because you want to believe that the head and the shoulders make sense together. Your brain does that very well.
But there's another way to do this, okay? Because back in the 70s, when I came to Texas and or California, went to Disneyland or something, we saw these eyes, and they were just fixed statues, because there's no animatronics really then. And however you'd move around, these eyes would seem to follow you. And somehow, somewhere, we figured out, someone explained how that works. So I made a set out of wood. And I'm not seeing myself. I don't know if this is coming across or not, but
it's really
so they kind of look like.
Oh, wait a minute! I got the wrong browser up. Sorry.
Yeah, they're meant to look like they're following you around, but you see what happens. The way they work is that there's just it's a detent. It's a concave thing in there, and because of that, the perspective, the depth thing makes it look like the whites, so it's following you around, no matter how you're looking at it.
Well, that's really what's happening here. If you look at it, you're actually looking inside. Let's see how to describe it. The nose is further away than the eye, but because you see it backwards, you see the nose is closer to you, and the eyes is further away. It's the same thing you were just describing. As you go through that, you can see it pop back and forth.
It's the game with depth perception, isn't it? Yeah.
Right? What you were talking about with the medieval artwork, there's a French phrase that means fool the eye, trompe l'œil. And that's what there's a whole bunch of artwork like that where if you stand on a staircase in a certain way and look up it looks like you have an arched ceiling when it's in point of fact flat. Because it's a perspective. It's the way the perspective works. There's a whole school of architecture like that. Then Europeans did a bunch of that stuff about 500 years ago.
Well, also where they do the chalk on the sidewalk, where it looks like it's stairways going down and things like that.
Got it. Posting a link.
Yep.
Okay, well, I'm happy to keep this on robot related. Now, it is robot related because that's an optical illusion that fools us humans with our enormous brains and our bifocal vision. So these are the kinds of things that artificial intelligence is going to have a hard time with. Real intelligence has.
Yep. His name is Jerry Andrews. I put a link in the chat of the Wikipedia of him.
Thank you, Harold.
Yeah, he was a neat person.
That's pretty cool. Was it just the one time you met him?
It was just the one time I met him. He was part of the Texas Association of Magicians, and it was down in San Antonio, and it happened to be my first year ever to go to one of these things. I had no idea who I was hanging out with at 3 o'clock in the morning, drinking water, getting amazed by what you were just holding in your hand right there. I had no idea what I was doing. If I'd have known, I would have just never left the room. I'd have just continued to hang out with the guy. I could have done it all weekend long.
Very cool. All right, hey, so another topic before it gets too late. So this Saturday we have a monthly meeting coming up, and I have somehow fallen down on the job. At least I haven't been able to figure out a normal kind of presentation, but we have a proposal on the table, and if there's no objections, I think we ought to run with it. And that is that, or unless somebody has another idea, please put it out there. But we seem to be on a roll with this virtual line follower, and Ron has new stuff to show, and I think there's still people that haven't necessarily tried to install it. So the idea for this Saturday was to go ahead and let Ron give a demo, a little more thorough than what we had this evening. And then we could also have a workshop part where, you know, if you haven't tried it already, share your screen and we'll help you get set up and started and try and get going with it. And then it could be a kind of a kickoff lead-in for contest in December 12th.
Yeah.
Sound good? Anybody have any better idea? Any additional ideas? Any ideas?
I'm recruiting myself because I'm going to be gone on Saturday.
Oh, that's cool.
I would say that sounds like the plan because I don't have any better ideas.
Okay. Well, this is good. Maybe we could get a couple more people to install this.
Maybe Chris will do a little demo of his 20 seconds.
Yeah, maybe we can get the trash talk starting early.
Yeah, there you go. And I will blow you away.
Maybe try and step up by then. I have to look at my fast time. Great. Okay, cool. Well, I'll send an invite out and
Harold, can you record that too? Because I'm going to also be out of town
on Saturday.
Yeah, yeah. Are you going to be able to?
I may not be able to. I think the wife has me going to something that I'm more than happy to spend time with the wife going there.
I used to do that, so I'll record it.
Okay. All right.
Yeah, I'll grab a laptop and record it.
Okay. Thanks. Because I'm going to be out of town too.
We'll miss you. All right.
Going somewhere good there, Doug? Going somewhere good?
Well, actually, it's my two grandsons, my son-in-law, and I are going down to South Texas to a youth hunt where they hunt. The two boys will have guns, and the adults just kind of like make sure they don't shoot their foot off. And they'll actually do 2 days of hunting. So I did it last year. It was a lot of fun. I actually dressed my first deer. You know, I had never done that before. And I thought it was kind of interesting.
Did you drink the blood too?
No.
No. Isn't that supposed to be part of it?
I think no. Well, I think if you're up from like Minnesota or someplace up there, and you're a hunting family, they often, when a kid kills its first deer, they'll put blood on its sheets and whatever.
Oh wow!
Those Minnesota people, man. I'm just saying.
Yeah.
Actually, I saying all that, those border waters up there, this is like 40 years ago. Yeah, 40 years ago. I went on a canoe with the Boy Scouts. There's a canoe base up there just on the border, those border waters, and that's
boundary waters.
Boundary waters, yeah. I will tell you, we were in Canada and in the United States and Canada for like 10 days out there going around doing it. And it left such an impression on me. I visit that place a few times a day just by closing my eyes. I see stuff so crystal clear in my vision. It was just, there's only one way to get memories like that is to actually go and do that thing. And it's just amazing. It's an amazing place. Amazing place.
Yeah.
Very cool.
Well, gentlemen, I've got to get back to work.
All right.
Stay cool, Murray.
All righty. Well, so what do you think, guys? Should we keep chatting or call it a night and then just head towards Saturday?
I think I'm about faded out. So thanks everybody.
Aim for Saturday. I
Ron needs to sleep 2 hours so he can code some more. So okay.
Try to get a couple bugs.
So I assume we're going for 1 o'clock for Saturday then?
Yeah. I didn't catch if Marie would join or not, but let's just do 1 o'clock on Saturday.
Cool.
Okay.
All right. And thanks again, everyone. And thanks, Harold, for recording. And we'll see you Saturday.
Not a problem.
All right. Bye.
For now.
Bye.